All right, guys, here we go. All right, so let's go over these. Yes, I did. So we got a function. I gave you the function g of x equals that. So this is the name. This is function g. So that's the name of our machine. You will be plugging x values into it. So x will be going in. This is what will happen to the x values that you plug in. So that's the rule that would live inside of this machine. And then you will get a number out as the y coordinate. That's how this works. So when I ask you to go find g of -1, does anybody know in words, what does that literally mean to do? Nice and simple. Plug it in, right? Go to function g and plug -1 in for x. Guys, this is g of x. Whatever number they put inside of those parentheses is the number they want you to plug in. That's your input. That's your x value. So right now, -1 is going into this function for x. So let's write that. So let's rewrite our rule. It starts with a 2. It's timesing with the absolute value of not x. They told you who to plug in for x. So -1, beautiful. Subtract 5, close catapult, and then -4. Yeah. Now you are just left, guys, with a mathematical expression. This has no variables. This has no equal sign. It's just simplify it. Use your order of operations to get this down to a number. So just like parentheses, let's do inside the bars first. So guys, what's -1 minus 5 more? -6. Then you have to take the absolute value of -6. What's the absolute value of -6? 6, which is then attached to this 2 by what operation when they're attached? Multiplication. So you're going to take that +6 and you're going to times it with the 2 that was attached to it. And then you're going to have to subtract 4. So now what's 2 times 6? Because PEMDAS would say to multiply first. 12. And then we subtract 4. And 8 is the number that comes flying out of this function when you plug a -1 in for x. So now we can say g of -1 is equal to 8. It tells a story. When I go to function g and I plug -1 in for x, I will get an 8 out as y. Or you are allowed to write this as an ordered pair. I don't think Delta Math asked you for it. I just want you guys to know it's a thing. You are allowed to say that -1 went in as the x value and 8 came out as the y value. And then you could create ordered pairs and even start plotting points and making a picture of this function. All right, go to the next one. Same function, except this time they said find g of 4. So give me a really easy phrase that this means. What does it mean to find g of 4? Plug it in. This is like directions, guys. Go to function g and plug 4 in for x. Whoever they put in the parentheses is x. So we're going, and now we're plugging 4 into the machine for x. So let's rewrite our rule. 2 times the absolute value of not x, we're plugging 4 in. And then -5, close catapult, -4. And now again, it's not an equation. It's not an algebraic expression anymore. We don't even have variables. All you gotta do is simplify this down to a number. So use your order of operations. So inside the bars, what's 4 minus 5? -1. Then you have to take the absolute value of -1. What's the absolute value of -1? 1. Then you have to take that 1 and times it with the 2 that is attached. So now it's going to be 2 times 1, and then you still have to subtract 4. What is 2 times 1? 2. Subtract 4, and the number that comes flying out of this function is -2. So now when 4 goes in, a -2 gets shot out. So now we could say g of 4 is equal to -2. Or you could write an ordered pair that says 4 went in as x, and -2 came out as y. All right, we good? All right, now we go over here. Guys, I keep telling you, with functions, it's kind of like a two-way street. Either they're going to give you an x value that you plug in and then see what number comes out. Or they're going to tell you what number came out. You have to figure out what number went in. So guys, do you realize, where was 4? He was inside the parentheses because that takes x's place. Where was -1? He was inside those parentheses because that takes x's place. Here was 10 inside those parentheses? No. So he's not an input. The biggest mistake students make is they just get used to plug in, plug in, plug in. This ain't a plug-in. This literally says go to function g plug some x value in. We don't know who, just make sure that 10 comes out. So right now, x went in, and we know that 10 came out. We have to find x. So we have to figure out what number went into this rule to make 10 come out. So set your function equal to that 10, and we have to solve for the x value that went in.
Yeah, I got that one.
There you go. So then we're going to get this. So basically, you have an absolute value equation to solve. How did we start every single absolute value problem? Add 4. By what? Add 4, because what are we trying to do? Get the bars alone. So let's add 4, the one that's not attached to the bars. All right, then we have 2 times the absolute value of x minus 5 equals 14. What are we going to do last to get those bars alone? Divide by 2. And then look what you're left with. You're left with the absolute value of x minus 5 has to equal 7. Guys, if I just wanted you to solve x minus 5 equals 7, there would be no need for those bars. These bars are here to tell you that it's not just one equation. If you are solving an absolute value problem, then most likely how many equations are there going to be? 2. Because guys, in math, how many numbers have an absolute value of 7? 2. What 2 numbers have an absolute value of 7? 7 or negative 7. That means that inside the bars, x minus 5, it could have become 7 because the absolute value of 7 would have been 7. Or inside the bars, x minus 5 could have become what other number? Negative 7, because the absolute value of negative 7 could have been 7. And now you have 2 teeny tiny equations to solve. All right, what are we going to do? Let's add 5. And we get x is who? So 12 is a number. So that means if 12 goes into this function, 10's coming out. And then we come over here, we add 5, and now we find out what's negative 7 plus 5. Negative 2. So the 2 numbers that could have gone into this function to make 10 come out are 12 and negative 2. So guys, it means this. When 12 goes in, negative 2, oh my gosh, sorry. 10 will come out. Or when negative 2 goes in, 10 could come out. And guys, do we care if the y-coordinate repeats? No, that's still a function. So who cares if 2 different x's made the same y value come out? That is perfectly fine in the function world. We just wouldn't want another ordered pair to have the same x coordinate and then have a different y coordinate. All right? All right, perfect. So guys, that's how we evaluate functions. And then this is how we find the input when they give us the output. Do you see the difference?
Yes.
Yes? Okay. All right. You have the rest of the period to either work on yesterday's homework, which was, I think, homework number 3. It's on Delta Math. It is due tonight at 11:45. Get that done. Then I created an assignment for today. It's called classwork. It's day 4, and I did not make that due until Sunday night. So on today's assignment, I wanted you guys to do this again, and then I added a couple review problems in there. And then Monday, we'll take our official review in class on Delta Math, working together. And then Tuesday will be our quiz. I think I'm going to do it on Delta Math. Okay? All right, so work here. Guys, ask me 1,000 questions. Let me go through this. Let me help you with you.
Delta Math, that always mess up.
I like Delta.
People always tell me they like Delta Math better.
That's so much better than.
Just because of typing.
You get to read it.
No, and I'm with
Yes,
you.
so one.
No, so she gets it.